Thank you. Yeah, I'm one of the organizers of PyData Berlin, so thank you for showing up. I hope you all have a great time. And we will start the meetups again every third Wednesday, probably starting from next month, so maybe see you around there. Yeah, my name is Daniel. I work for DB Systel, and for the first time we are one of the sponsors, so if you are interested in jobs, you can go upstairs and talk to us. Yeah. So I'm a data scientist, and a couple of years ago I had to do some Sankey plots, and I was like, maybe I should do a talk about it because you don't find that much stuff on the internet. So maybe just start really from scratch, what are Sankey plots? And basically Sankey plots are just flowcharts where the flow has a certain width, which stands for the amount or the volume of that data. They are named after Matthew Sankey, who was an engineer and did a paper on steam engines. And he made this Sankey plot that you can see an extract here, where he basically, you see the distribution of heat in such a chart. So he compared the current model to some idealized version of it. So he did that in late 19th century. Actually, the first Sankey plot is almost 100 years earlier, from Charles Minard, who visualized this, Napoleon's route to Russia. Probably many of you have seen this before. It's one, I guess, of the most famous graphics. And in this 2D graphic, you see many data types. So you have location, you have the amount, the width of the flow. You have temperature and time. So you have a lot of data types here. But this is kind of a Sankey chart in its most original way. Nowadays you see it much more often with energy flows. So I have two examples here. The International Energy Agency shows this energy flow of the entire planet. And when we zoom in, you can see some different energy sources, and you have some steps here with production and import and export. And you can filter that by year. So it's kind of interesting to see how that changed over the years. Also with Eurostat, a European website, you can see the kind of the same stuff that as before. So it's an interactive energy balance from all the countries of the European Union or the whole European Union. So you can filter that as well between different years and different countries. So if you look here a little bit closer, you can see imports and exports, and you see those different distributions. Each color stands for one of the energy sources. So you see different steps along the process from production, import. They have some transformation here, and in the end you have consumption, exports, and some waste in the process. So I guess that's quite important to see. You have different steps. You have different categories, and with those flows you can see the distribution of those categories at a certain moment in that process. So how are they used today? I guess many of you see maybe those voter flow charts in elections now. I found that for a German election from last year and 5 years ago. So you see the different parties color-coded with different colors. And then I guess with the Sankey chart, what do you really want to show or highlight is the flow. So the question is, where does something go to? In that case, you see one party on the left side, which is highlighted in red, and then you see the flow of voters, who voted again for the same party or who voted for different parties. At the same time, you can just reverse that, and you can ask the question, where does something come from? So if you see now the Green Party on the right, you can see how many voters stayed the same and how many voters from different parties voted now for another party. So I guess the main focus on those charts is basically to show you where does something come from and where does something go. You can also extend it. So here you see a Sankey plot from The Economist. For the British election, for a couple of years. So you can extend the y-axis for multiple years, as you can see here, and make it much more interesting for more than just 1 year. So just to get an idea what Sankey plots are about. So basically you have a flow of different categories at 2 or more steps. With the German election we had 2 years. that we compare, and with the British one we had 4. For the energy charts also we have different steps on the process, and the important part is like the flow of the data. So you have like a redistribution of those categories, usually going from the left side to the right side. Yeah, and those distributions you can basically just calculate. Like they are kind of implied because you can just sum up all the flows of one category at the step. Yeah, and then kind of important to highlight, like the width of the line should always represent some volume or amount. Like if you see some really bad examples that doesn't really match up, then it's kind of difficult to understand and maybe like misleading in some way. So the idea of my talk was just like how to do that with Python, right? So like I had a customer, we had some data, and I wanted to do some Sankey plots. So I just tried some libraries, and for this talk now I just started from scratch, see how easy is it with different libraries to get started to make such a Sankey plot. So first I wanted to get some data from the Deutsche Bahn, like how, which energy do they use, but I could only find the distribution of the data, but not the flow. So it was like, yeah, too bad. So I looked further and I found the like some census data from Berlin, where you can see, different years here. You see some kind of, beginning of the year, how many people live in Berlin, how many people are born, how many people died. You see how many people are immigrating and emigrating. And then you have like a total of the year, and then like a total number of people living in Berlin at the end of the year. What's kind of interesting, what maybe you don't see in the beginning, the numbers don't match up. So I was kind of confused because, I recalculated the lines and was like, that does look kind of weird. So there is some kind of error in here, which is not that small. And I was trying to find out where this happens, and I guess it's just different, like governmental agencies calculate the numbers differently. So you just have like an error in here, which is, seems like people are disappearing in Berlin. So I tried to, just took those numbers. Here you can see this error of like almost like 4,500 people, which were just like disappearing. But I just took those numbers from the sheet, gave them some names, and this is kind of like how to get started. So first library, obvious choice, Matplotlib, I guess everybody knows, like from NumFocus, like sponsored project, and they have like just a Sankey class which you can import, and many examples. So I started, importing the class, initializing the class, and adding a flow, and that was the result. So it was like, what happened here, So you go through the documentation, and I found this like magic scale keyword. So because the numbers are quite high, Matplotlibs kind of expect numbers around like 1 to 10, I guess. So large numbers, small scale, like it looks better, but still it's kind of not what I'm supposed to like wanted to show. So, just going further in documentation, orientations is kind of the keyword. So with orientations, you can tell Matplotlib where does something come from and where does something go. So the 0 here stands for it comes from the left, goes to the right. So I took that for the beginning and the start. And the end of the numbers. And then with -1 and 1, you can kind of tell it, does it go to the top or does it go to the bottom? So, with like just a few steps, it looks kind of okay. But yeah, I guess it could be better, right? So I found this path length attribute where you can just say, with the error, it goes a little bit like longer, so it's easier to read, So finally getting somewhere which like looks kind of close to the original Sankey plots. Like seeing those numbers, right? Like the scientific notation doesn't really help me here too much. So I just wrote like a small method for adding this like 1000 separator and getting rid of this like scientific notation. So, kind of getting somewhere. And then in the end, I was just like, just removing the color because I don't need it. Like blue doesn't show me anything here, and adding a title. So I guess, kind of what I wanted to do. Easy, but like you have to do all the steps explicitly on your own. So Sankey plots, I guess, get kind of interesting when you add more steps. So it was like, how easy is it to like add another year? So I edited like 2019 data as well. So you can see here like almost 3,000 people disappeared in Berlin, wherever they went. So just like doing the same as before. And I guess the most important part here is like you have one object, you just use this like add method for adding data from different years. And then the second flow, you can see you have a prior and you have a connect. So you kind of tell it where do you want to connect the second flow to the first. So that was kind of easy and straightforward. Well, like a little bit surprised how easy that was, but yeah, that was kind of like, getting started with Matplotlib. So it is quite original to like the original flow chart and like the, the Minard chart that you have seen before. You, on the other hand, have to do all the stuff explicitly. So you really have to tell Matplotlib what you want to do, but at the positive side, you really can tell it what to do, right? Documentation is good, but it's a lot. So like you don't, where to start. It's just a lot, but at the other side, there is a lot of documentation. I had some pitfalls with the scale and the format arguments, but I guess like Matplotlib is so well used that you can find all the stuff on Stack Overflow and really can do something. But tooltips or something like that, it will just take a lot of programming, and yeah, you know what I'm talking about. So I looked at GitLab for like some small projects, how to get started, and I found Sankey, which is I guess just like a single girl doing that. So I imported it, and you can see now here pandas. So that's great. Just get data into a data frame. So that's much easier to handle. So I created like a data frame from the 2020 data, just with like the actual flows. Where's the start? Where's the target? What's the amount of people? And then it's just like magic, you tell it where's left, where's right, what's the value, and like that's basically it. So that was quite cool to get started. At the other side, like documentation was not that good. Some stuff didn't really work, and you can't really add more than one step. So I guess it's good if like the chart that you just saw is what you want to have, but you can't really go further than that. So it's a lot of try and error. You don't really have documentation. Some stuff is like missing, but I guess it's good to get started, like simple plot and like a data frame. So I found another one, quite similar, Sankey. So I installed that, imported it, used it, just use the same data frame as before. Works in a way, right? At the same time, you can't really, change a lot, but I think it looks a little bit better at the other side. I don't know why they have the lines like, coming from down left to top right. I guess could be better, but it's all like magically calculated somehow. So just doing the same stuff as before, adding the 2019 data, just have the data frame. So like with that library, you can add multiple steps, which makes it, I guess, like much more usable. Easy to get started, like not that easy to like really use, right? It's a little bit crowded on top, hard to read, but at the other side, not a lot of code, right? It's just give it a data frame and the rest is like magic. So also works with data frames. You can have multiple steps now. It is a short but helpful documentation. There are like some really smart ideas here. So like there's one argument where you can like highlight some nodes. So I guess when you really want to say, that's what I care about, that's kind of easy. But I haven't found like an easy way to customize where the nodes are positioned, and then it's kind of, crowded on top and difficult to read. So getting more like in sponsored projects and like much more, bigger libraries. So HoloViews is sponsored by Anaconda, and it uses the Bookie backend, which, many people probably know immediately makes it more interactive. So it's just part of the main HoloView library. So just trying to get the example running, just a few lines of code works immediately. So that was kind of fine. So I used the 2020 data that we used before, just the like data frame with 2020 data, put it in, works, and it's kind of interactive. So you see stuff here, which is, really nice. So I would say like that's much better, much easier than the stuff before. Yeah, and the nodes are kind of, yeah, make sense, right? So let's add another level, right? Like we have the two-step data, like the data frame with 2019 and 2020, just putting it in. Yeah, just works, you know, that makes it kind of easy. Coloring the like flows and the nodes made it, it's not that easy. Like you could tell it, you know, which attribute to use, and then you have to give it a color map. Yeah, which is like, yeah, I don't want to like, you know, spend an hour now just doing a color map. Maybe there's some easy part, but I guess like HoloView also on like Stack Overflow or something, you probably can find some hacks to do that. So like HoloView, like with DataFrame, super easy to get started. You have all the like interactivity with the Bookie backend, like you do tooltips and that stuff. You have a really short user guide with only a few examples. So I guess it would be nice if there would be just more to get you started and makes it easier to, you know, see how it's done. And I couldn't really find a way to change the node position. So I guess that's also like something, you know, when you have all those nodes, you know, on top, could be better, I guess, in a way. But maybe it's possible, you know, like probably some people hacked it in a smart way. So yeah, last library that I checked was Plotly, which I use at work right now. So I don't know how free it is. I guess you can use it free, but then for companies you have to pay for it. But I guess Plotly also has like a lot of stuff. So just imported Plotly. You see code gets a little bit, you know, more. So I was just trying to get the example running. So you import this like Sankey class here, and here we have some, like we define nodes first, and then we define the flows. So this is just the example data with some like random labels and random links and values. So this is basically how the Plotly example like, yeah, looks like. And you know, with the open source libraries before, you install something, you try to get the example running, it doesn't work. I was like, yeah, just, you know, start simple in the beginning. So, yeah, I changed the data a little bit now. So it is basically the same as before. I just added colors here. So you see this data frame now, and we have this like C, like the C value here, which is just colors of the different flows. So it was like, yeah, let's make it more like readable and then like, yeah, prettier. So it's basically the same data frame as before, 2 years with the color column. So yeah, I found this like hack for Plotly to use data frames for Sankey charts. So it's just like making a unique series of all the nodes in source or target. So we can use those like indices for all the other yeah, attributes that we need. So what do you see now? We define like the nodes, you know, just a list as you see before. We have like the node indices, and then we have links, you know. We add the source to the target with the value. And looks like that. So I like that way more. You also have tooltips again, like it's easy to add a title. Yeah, you have all the stuff, and it looks kind of pretty without changing too much. It was kind of surprising. Yeah, at the same time, you know, it's not perfect. Like it's all crowded here. You can't really spot the difference, and we're like, where does something come from? Where does something go? So it was like, yeah, how can we improve that? So what's kind of cool but difficult is you can really change a node position now in an easy way, but it's kind of complicated. So you can define like X and Y values for all the nodes. So it took me like a lot of try and error to like get it where I wanted it to be. So this is how it looks. You just like give it kind of a position, X and Y. I also gave the node some color. So yeah, it took me probably half an hour to just like, you know, change like a 0.3 to a 0.2 and see how it looks like. But yeah, that's what I did. I found this padding, or like pad attribute as well, which is just like giving some space between the nodes. I give the link the color, and yeah, this is basically how it looks like, which is like, yeah, we have simple colors, we kind of know, yeah, we have tooltips, and the nodes are kind of where they are supposed to be. Like for me, this is kind of what a Sankey should look like. And with Plotly, in that case, it was the easiest. At the same time, it's a lot of lines of code just for like a simple Sankey chart, right? But I guess it's not that easy to automate all that. Yeah, so yeah, Plotly was very adjustable, interactive. You can move the nodes, so that was the only library that I found easy to really change it, even though it's kind of like tricky to do. You have many examples, which is great. Yeah, and yeah, difficult to arrange, but you know you have all the power, which is great. So like just some takeaways in like regards to Sankey plots. So I guess it's quite important to know what do you want to show, right? Like, are you interested in distributions? Then you should probably take like a bar chart or like maybe a pie chart if you don't have too many categories. But if you're interested in flows, you know, you have to fit, is your data right for flows? You know, if you only have the distribution data, that's not enough to create a Sankey. You really need the data for it, which can be tricky to get. And in my experience, it only looks good if you don't have too many categories. Like I will show you some like good and bad examples now, so you can like I guess you see quite quickly what I mean. At the same time, like make sure it's worth the effort. Like it takes time. It's not that easy to do. So getting your data in the correct format and then like customizing the plot over and over until you are at a point where you're like, this looks great. Yeah, it's tricky. And then in the end as well, like think about colors, right? Like all the default colors are quite, yeah, heavy. So if you find some good examples, that's like, yeah, easy to guide you. So just some examples, you know, we've seen that before. This is something I kind of like, it's easy. I also like Economist one, like they have really good like color codes as well. Like all the stuff in like good newspapers, they usually have good people like with data visualization skills, and yeah, always good to see those examples. I found this example, which I really like, which is like petroleum in like where, you know, something comes from, what imports. I think that's kind of like, you know, easy, like not too many colors, like just one scale and kind of, you know, easy to read. So I really like that example. And then maybe just some I found which are kind of like bad, which is like, yeah, kind of, yeah, you know what I mean. Too many categories, weird colors. You don't really see anything apart from like a few countries that stand out. And then I found that one, which is probably the worst I've seen in a really long time. And somebody completely, yeah, used it incorrectly. So I guess like the colorful arrows, like just here on the bottom, are kind of the ones going out of the blue arrow. So they're even like on the wrong position. And yeah, the width just doesn't make any sense at all. Yeah. So yeah, I just like put the links here. On the bottom you see the libraries. On top you see some like further reading. And like you can get the slides here. That's maybe the easiest to get started, like get the links. And yeah, I hope you learned something, and I'm open for your questions.
Thanks a lot, Daniel, for this presentation on Sankey plot. Yeah, I think I already went through, and it has been quite painful for me, painful experience for the Sankey plot. We have some question. One question about how do you present the can you present the Sankey plots from right to left for some language we are reading from right to left?
What was the middle part?
Can you present some Sankey plots? Like, does the option exist to present from right to left for the language you are reading from right to left?
I guess good question. I guess you could just change it around, right? Like, I guess Matplotlib, the arrow, like, I guess it should be hackable in that way. And I guess like for all the other ones we saw in the end, you just change around the order, and then it should work.
Thank you. Just a hint from Mike, who says that on Matplotlib, it can be, usually start with the Matplotlib website, and it can be more complex Sankey diagram too on the Matplotlib website. And another from Pierre-Olivier, who is saying that you can reorder the nodes in a Sankey with the whole of these by using .redeem. Mm-hmm. But yeah, just some remark.
Okay, yeah. Yeah. Thank you.
Okay. if you have any question in the audience. Yeah.
Thank you for these votings. Looked great because there were like a lot of change. Like some parties just like lost a lot of voters, and Berlin population kind of hovered around 3.6, 3.5 million, and like the differences we were interested in were just like a couple of thousands. Do you think it's like, or is there some option to kind of break like these 3.5 million of Berlin inhabitants we're not that interested in, to see like these little errors like better? Is there some visualization tool? Do you know?
You can just like, divide it, by a few hundred or something, just make it, steady, or just remove it completely, If you're not really interested in the total population, but just the change, I guess it makes sense to just remove it, because, you're just interested in like how many people come and how many people go. So yeah, I guess on that regard, like if it's difficult to read if you have like one really large numbers and the others are kind of small, so maybe just removing it if you're not interested in it makes it easier.
Okay, thanks.
We still have time for another question. Okay, then. Thanks a lot, Daniel.